Students, today we'll have a small idea. Okay, it's just converting from explicit to recursive and vice versa. Now, of course, it is like it's a small topic, but it's worth mentioning. Okay, so from explicit to recurring, we would have this given in the arithmetic. We would have the d and we would have the k. Okay, now the d is basically the common the like the common difference between the terms. Okay, so since we have d, we can easily write ur plus 1 in terms of ur, but we want u1. Basically what we do is we just substitute 1 in ur that is given here. So for example, let's say ur equals 6r minus 1. Now we want u1, so it is 6 minus 1, which is 5. ur plus 1 equals ur plus d. What is d here? It's 6. Easily. Okay. Now for the geometric sequence, we have a similar approach, but like somewhat easier. Okay, so we will be given the k and the q. Okay, which are the ones that we want, or we just want the q. The k and c are just like given to calculate u1. Okay, so basically, let's take a small example. Uh, as I said, it's the same idea. It's q here times ur. We have q, so this term is very like gettable. Okay, and since we have ur, we can obviously get u1. So let's take an example. Let's say we have ur equals 5 times minus 2 to the power of r minus 20. Okay, it doesn't matter like what number is here. Okay, let's say it's 67. So we want to calculate u1, so it's basically 2 1 minus 67, which is of course an insanely large number. Now let's calculate ur plus 1 is basically minus 2 times ur and u1 equals this insanely huge, or rather small, number. Okay, so that's it. Now we will see now how would we convert like from recurring to explicit. Now first thing first, we have to know is that when we write this, okay, in general, even if like forget about converting, when we are writing this in general, okay, here most of the times it's 1. Okay, but sometimes it's not 1, it's n. And when it's n, we have to put a condition r is equal or greater than n, because look, the common difference is the same, and the how it grows is in the same. Okay, but the only difference is its starting position. So sometimes in some rare cases it starts at like term 7 or 9 or 10, so we can't really calculate u1. Okay, so this is just like a small um hint. Okay, so obviously we have this is kind of more straightforward than the one before it, because this is kind of just like applying the manual. Okay, let's take an example. Okay, let's say we have given u1 equals 7 and ur plus 1 equals ur plus 4. Okay, do we have un? Yes, which is u1. Do we have n? Yes, it's 1. Do we have d? Yes, it's 4. Okay, then it's solved. So easy. ur equals un, which is here 7, plus r minus n, which is basically r, ways r, okay, r is 1 here, what, r, no, okay, sorry, r minus n is 1 here, times d, which is 4. Now we just expand it and it's there. Now for the geometric one, it's kind of the same, okay? So this is why I said that this is kind of a small topic, because it's not really like a major one. It's just like, hints. Okay. So let's take an example, shall we? Okay. So we have u1 equals 3, ur plus 1 equals 2 ur. We want to find the explicit form. Okay, easy. ur equals, do we have un? Yes, which is 3 times q. Where is q? It's 2. R minus n, r minus n here is 1. R minus 1. So it's ur equals 3 times 2 to the power of minus 1 times 2 to the power of r. Here's, it will go to the denominator, and this is it. That's it. And thanks.